Today, stormwater management BMPs and low-impact development, or LID, are increasingly made a part of the construction process. What was once considered an add-on is now seen as an integral and sometimes required part of landscape and site engineering. Hi, I'm Kara O'Brien. In this video, we will discuss types of stormwater best management practices, their construction elements, the importance of proper construction sequencing, and construction techniques. So, what is a stormwater best management practice? And what is LID? The EPA defines stormwater BMP as a technique, measure, or structural control that is used for a given set of conditions to manage the quantity and improve the quality of stormwater runoff in the most cost-effective manner. Low-impact development is an approach to land development that works with nature to manage stormwater as close to its source as possible. LID employs principles such as preserving and recreating natural landscape features, minimizing hard surfaces that increase stormwater runoff to create functional and appealing site drainage that treats stormwater as a resource rather than a waste product. Some of the more typical stormwater management BMPs and LID practices include bioretention, dry swale or bioswale, surface sand filter, and vegetative conveyances. These practices all are constructed using similar materials and techniques and function in a similar way by filtering stormwater using sand, soil, and in some cases, plants. We recently visited with Ted Scott of Stormwater Maintenance LLC, who described the basic features and functions of a bioretention facility.
Bioretention facility captures stormwater, hold it, slowly filter it utilizing a soil media. So below the surface of this facility is 2 or 3 feet of very sandy soil mixture. There's an underdrain system beneath that, so when the water goes into it, it captures and holds it, filters through the soil media, and goes out the underdrain below.
Thanks, Ted. We are about to look at important elements of the stormwater BMP construction process. But first, we need to know why contractors and homeowners should understand the details and sequence of stormwater BMP construction. The construction sequence for stormwater BMPs is process-driven. Working out of order, skipping steps, or ignoring details can result in significant problems, both near and long-term, and even result in practice failure, which can negatively impact nearby property and resources and lead to the need for system replacement. Here is a typical construction sequence for building stormwater BMPs. Start by locating and marking underground utilities. Next, stabilize the drainage area. Then, install sediment and erosion control measures. Properly select and use equipment for excavation. Next, ensure the base and the slopes are as designed. Ensure the materials meet the specifications in the design. Properly use filter fabric. Install underdrains and cleanout. Compact the site properly. Ensure elevations are correct. And finally, install vegetation and mulch. Now, we will examine each in more detail, following the typical construction sequence, explaining the importance and the pitfalls of not following proper construction procedures. First, locate and mark underground utilities. As with all excavation projects, buried utilities are always concerns. During this first step, ensure that all lines are marked before beginning to dig. Be sure to utilize as-built plans for the site to identify other utilities that may not be marked by the utility company. These can include electric to light poles, cable and phone lines, irrigation lines, and other existing underground utilities. Other considerations include maintaining cover over known utility lines while in the construction process, especially water lines that might be susceptible to freezing. Next, stabilize the drainage area. Immediate problems can occur if the contributing drainage area is improperly stabilized. This, along with sediment and erosion control, are essential BMPs for all construction projects. Runoff from rain events during or immediately following construction can send a flood of sediment-laden water into the practice, which leads to the clogging of the filter media and results in a BMP that does not drain or function properly. The Center for Watershed Protection's Laurel Woodworth recently spoke with construction foreman and certified land disturber Steve Seal to discuss how his crew would address these issues.
What will you do to prepare for any upcoming rain? Well, what we do on this one, and what I've talked to the engineer of record about, is that because I've got curb and gutter and stone in, we've put in a layer of geotech fabric on top, because the top elevation of that mix is a little bit lower than the surrounding areas. So what we try to do is we put a protective layer of geofabric over, so if we have any washing rains, and again, you're going to have sediment wash off the slopes, any sediment that's washed in will be captured by the fabric on top, which will be removed before it's all finished and final graded at the end of the job.
Next, use the appropriate size and type of equipment for the job. This is important so that the contractor can balance minimizing disturbance and compaction with maximum efficiency. Mini excavators, as shown here, can minimize site impacts and allow the operator to work in tight locations, while large excavators can quickly excavate larger areas and move heavier material. Prevent compaction of the bottom and the filter mix by keeping heavy equipment outside of the project area. For a larger project, it may be necessary to use a cell construction approach by breaking the project area into 500 to 1,000 square foot cells with earth bridges between for equipment access. The next step is proper grading. Site grades, slopes, and the condition of the bottom of the practice are critically important to ensuring the BMP functions appropriately. At this stage, it is important to ensure that water has positive flow and enters and exits the practice as designed. Stormwater BMPs are generally lower than the surrounding ground. Make sure the side slopes leading down to the practice are properly constructed. Most BMPs look to achieve a minimum slope of 3 to 1 to ensure that the slopes do not fail or contribute large amounts of sediment to the BMP. Make sure the bottom of the practice is level and use the rake technique with the bucket to rip and scarify the subsoil to maintain porosity. Next, material specifications are an important component in BMP installations, and one of the most common missteps in the construction process is using improper materials. Ensure that the stone being used is washed and the correct size. Use pipe material that is the correct diameter, schedule, and material. Confirm that the soil or sand is the correct mix, and use the appropriate ground cover, mulch, and plant material. Let's hear from Steve Seal.
57 stone is normally washed before it even arrives at site. The pea gravel is a little bit different because it's a finer stone. It's a number 8 stone. So when you get that on site, you need to make sure that that's been washed, because what you don't want to put in any layer that has any kind of fines or any kind of silt to it at all. Once you do that, then you run the risk of contaminating the filtering layers on any subsequent layers lower.
And how about the soil mix? Are there certifications for that?
Yeah, all of that mix is certified. This particular one is brownish in color. It's a very sandy mix. There are different certifications depending on what areas of the state or the country or the region that you're in. There is a perforated PVC pipe that's put in. That is the dewatering pipe for the biofilter at the bottom.
If any of these materials are incorrect or improperly placed, the filtration process can be slowed, or the removal of pollutant by the soil and gravel media can be negated. Along the way, it is important to check the elevations of surface and subsurface layers, underdrains, berms, inlets, and outlets to ensure the function of the practice. Even minor deviations can result in significant problems with the overall function of the practice. Here is Ted Scott, who discusses a failing system due to improper elevations.
Here we're at a bioretention facility that got some problems, we'll say. And it's important to identify what the problems are when you see them in the field. Some of these problems were driven by the design. One of the more challenging things with designing bioretention, because it is a parking lot island, it is in the middle of the site. Elevations, the grades that were designed on this particular site, leave a little bit to be desired, because on the side where I'm standing, it's about 1.5 feet lower than the opposite side of this parking lot island. That grade difference is fine, except the bottom of the bioretention facility is losing not only the gravel due to erosion because of the overly steep slope. We're starting to lose the parking lot and starting to lose the curb edge.
Filter fabric can be used on side slopes, but should never be used on the bottom or in between the soil and stone layers unless an approved geotextile with a proper flow rate is specified by the design. Many practices utilize perforated underdrains to ensure the system drains at a desirable rate. These pipes need to have secure connections to prevent clogging and breakage. Additionally, cleanouts will need to be installed and angled properly to allow long-term maintenance and make certain that all segments of the pipe can be cleaned out. The different layers of the bioretention system should not be compacted to the point where percolation is impeded. Proper compaction of biofilter and sand comes from watering and light tamping only. During installation, allow for 10% settlement and avoid compaction of the sub-base. However, berms, side slopes, and conveyance swales should be properly compacted. The installation of the plant material and mulch is not just for aesthetics, but an important functional feature of LID practices. It is crucial to use plants that can survive the harsh world of a stormwater BMP and be able to tolerate both extremely wet and extremely dry conditions. Ground cover typically consists of mulch, turf, or stone. It is important to inspect the thickness of the mulch or stone layer. A common problem is too much mulch, which can displace ponding volume and change flow paths. Make sure the ponding depth is at the specified elevation, usually 6 to 12 inches. Plant trees away from underdrains and stake trees if a sand media is used. So what are some of the benefits of stormwater BMPs utilizing the LID approach? We recently spoke with several community leaders about why they're utilizing these practices and some of the benefits they have received.
For the last 5 years, we put on our agenda that we wish to become more environmentally conscious. In doing so, we decided to change our main street, Decatur Street, into an environmental model for the nation. The main reason being the Anacostia River is right here. And we wanted to make sure that the water that leaves our streets is pure. A lot of folks don't understand. The first 1/10 of an inch of rain that comes down washes your streets. And this takes away all of the poisons, the mercuries, and the oils that are on your street and brings them down into the stormwater system. Well, all our bioretention systems are before they ever go down the sewer. All these grasses, trees, that we have in there take the poisons out, give us pure water to go into the Anacostia.
We're the last municipality that ever touches the Oxen Run watershed before it empties into the Potomac River. We have 7 rain gardens. The benefit from doing this is it keeps the water from going into the tributary that we have running in front of our building polluted. And education and being able for people to come and visually see how all of these best management practices are working. Once they can see them in operation, they can say, oh, well, this isn't so bad, or I can have this rain garden in my yard. They can visually see it.
My name is Tom Schueler, and I love rain gardens, and so I built some in my home. I did it for a couple of reasons. The biggest one was to keep my basement dry. Every time it rained, a big storm, my basement got wet, so I just had to move the water away. But I also wanted to create a nice planting bed where I could put in native plants that would attract birds and butterflies. So I thought it really solved my basement problem and added some nice landscape features to my yard.
In this stormwater practice construction video, we learned why people build stormwater LID projects, the importance of following the construction sequence, methods to keep sediment out of your stormwater BMP during construction, the benefits of different types of excavation equipment, how to use equipment to reduce site impact and improve project performance, the importance of checking elevations throughout the construction phase, how to avoid unnecessary compaction. To learn more about stormwater practice construction, LID practices, and other strategies we can use to protect and promote healthy neighborhoods and cleaner water, visit the Center for Watershed Protection website and sign up for our educational webcasts. Also, see companion resources such as the Chesapeake Stormwater Network. Please share this video with your friends and colleagues on Facebook and Twitter.